Okay. Just do the stuff you remember how to do, and then if you have questions, I can come up with you. All right, here we go. So last time, what shape were we graphing? Do you remember? Yes. You were here last time, so I actually want you to do the note, but you'll have time. You were gone last time on Tuesday. Oh. And you're gonna be. Yes. Were you here last time? Tuesday? Yeah. Okay, I would do the notes then. So that way you don't have to like rewatch them later, because that's really it's about long. Tomorrow. And go ahead and I'm gonna give you this, but if you did the notes last time, you said something. So I would just kind of. Okay. All right, so remember last time we did a circle. So today we're just gonna do an ellipse. Okay, but it's very similar. So take a look at the top of your notes. Okay, a circle, you have the same distance all the way around, versus an ellipse is basically just a fancy way of saying an oval. So draw an oval for me real quick. Like that. Okay, so I'm going to put an ellipse as an oval. Oh, oval goes. Okay, but then it says it has two distinct axis distances. So one of them is going to be the major axis, which is the longer one, and then the minor axis. Okay, your major is the longer one. So in this case, my major axis would be this way. And then my minor axis would be the radius up and down, which is the shorter one. Now, does the oval have to be fatter like that one? Or can it be up and down too? Like, think about it. It could be like this, or it could be like this, right? And now in this case, what's your major axis? The X or the Y? Your major would be the Y. So now this one's the major because it's literally just whichever one is long. Okay, and this would be the minor. So we're going to fill in the blanks up there at the top. It says the minor radius is the distance from the center to the circle on the shorter axis. And then the major is the longer axis. Okay, remember though, these are still both radiuses, kind of like we did last time. The only difference is it's not the same distance. Versus on a circle, it doesn't matter which way you count, it's going to be the same no matter what. Okay, so to account for the fact that the radiuses aren't the same, look at this number at the bottom. Your center is still going to be the H and the K, just like last time. Okay, and then hopefully you remember we're always taking the opposite of those numbers. So if it's a minus H and a minus K, then your actual center is positive H and positive. Okay, then your A is under the X. That means that it's the X radius. And then your B is under the Y. That means it's the Y radius. So I'm going to put here, A is the horizontal radius. And then B is the vertical radius. Now, remember, you'll know which one's major based on which number comes out to be longer. But this is extremely similar to what we did last. So when you're ready, take a look at, we're going to do number 1. Do your X and your Y's have any numbers with them to change your center? No, then your center is going to stay at 0, 0. So put your center right there. And then you're going to take your major axis is going to be the bigger number. Okay, so is 81 or 36 bigger on the bottom there? 81 is bigger, then my major axis is going to be y. And then I'm going to take the square root of the number on the bottom. What's the square root of 81? 9. Then on the y-axis, I'm going to go up 9 and then down 9 from the center. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, then the number under my x is going to tell me how far to go this way. So it's a 36, then I have to square root it. So what's the square root of 36 for the x distance? 6. And then I would go 6 this way and 6 this way. And then just kind of draw your oval. Okay, but you can see that they're not circles because you don't have the same radius all the way around the circle. If you measure it this way, it's one thing, this way, it's another thing. Okay, then also let's label this would be your major axis. And then this one down here would be your minor. Okay, but remember, it's just based on which one's longer. Okay? All right, now take a look at the second one. So very similar, but our center is different. What's our center going to be if I have a -2 and a +3? I have a -2 and a +3. Yeah, sure. And then don't forget to check the mode. If your answers are coming out wrong, you're probably in, you should be in degree. Well, she didn't know that she's coming, so don't mark her outside. Okay. So +2, -3 is here. That's my center. And then I'm going to look at the two numbers on the bottom and I'm going to figure out which one's bigger. In this case, which number is bigger, the 49 or the 25? And what letter is 49 with, the X or the Y? Then the X axis is going to be your bigger one and the square root of 49 is 7. So then in the X direction, that's horizontal. I'm going to count 7 this way. 1, 2, 3, 4, 5, 6, 7. And then 7 this way. 1, 2, 3. Okay, so it's going to be really wide. Now let's see how tall it's going to be. Under Y, I see a 25. Then I square root that. And what is the Y, the minor axis, going to be? Up and down, how many? 5, thank you. So then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then you can draw your oval, or your ellipse is technically what it's called. Okay, so it'll just be like that. And then you can label your major and your minor. Your major is the longer one. So in this case, this one is the major. And then this one is the minor. Okay, but remember, the longer one's major, shorter one's minor. Overall, makes sense, pretty easy. Okay, turn the page, look at the next one. There's one detail with this equation that you have to pay attention to when you're graphing. Since your radius measurements are down here, your equation should always be equal to 1. Okay, it's not equal to an r squared like on a circle. It's always equal to 1 because you'll have your x and your y radiuses down here. So turn the page, look at the next example. What is this one equal to? 4. That's not going to work. Then we have to fix it, but it's actually pretty easy to fix it. All that you're going to do is if I need this to be a 1, then what do I need to do on both sides? Do what? Yeah, well, I need to just get rid of the 4, so I need to divide by 4. So I need it to be a 1. So I'll divide by 4 here. And then if I'm going to divide by 4 here, I have to divide by 4 here, which means basically you're just going to times by 4 with what's already on the bottoms. Does that make sense? So if I need this to be a 1, I'm going to put needs to equal 1. Then in order for me to fix that, whatever number's there, I'm going to divide it all the way across. If there's already a number on bottom, then I'm going to multiply the 4. So now I have this. x plus 1 squared over what here? It was already a 4, now I times by another 4. Now it's a 16. Very good. Plus y minus 3 squared on top. That doesn't change. But I had a 25. Now I times it by 4. Then now it's a 100. And then the 4 divided by 4, that gives me the 1 that then I'm ready. So let's find our center first. Our center is the opposite of the x and the opposite of the y, which means it's what ordered pair? Negative 1, 3. Very good. Go ahead and graph that. Negative 1, 3 is here. And then which of the numbers on the bottom is bigger? The x's base or the y's base? Y's is bigger. It's a 100. Then my y-axis is going to be 10. How did we get 10? We took the square root. So then from here, I would go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then down 1, 2, 3, 4, 6, 7, 8, 10. So that one goes a little bit off the page because 10 is pretty tall. Okay, then my smaller number is a 16. It's matched up with the x. Then do I go 16 on both sides? Make sure you take the square root. So my x distance is going to be 4. And then you'll count 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. And then just kind of do your best to draw the oval. Okay, mainly what you're doing on your homework is either identifying the center from the graph or writing the equation. Okay, one more like that. Take a look at number 4. Are we ready to graph it right now? What's the problem? 3 can't be there. So we got to divide by 3, which means we're multiplying anything else on the bottom side. So I have x minus 1 squared on top. 3 times 12, what's that now? 36, thank you, plus, and then y squared over, I had a 3, times it by another 3, now it's a 9. And then your 3 divided by 3 over here is equals 1. It has to be equals 1. If it's not, you got to fix it. Then from there, you're just going to identify your center, check your x and y distances, and then graph your. So my center, negative 1 turns to a positive 1. What about if the y is alone? What's the y value? Can't be 1 or it'd have a minus 1. What should the y be? 0. If your number's alone, then it's just 0. What that means is like they didn't shift it like sideways at all. Otherwise, they would have put a number. Does that make sense? Should be 1, 0. Okay, so 1, 0 is right here. Then I'm going to check my major and minor axes by taking the square roots of the numbers on the bottom. Make sure they're always lined up with their partner. So 36 is bigger, but it's with x. Then I know the x is the major and 6 is the distance. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then for my minor, it's the smaller square root and it's matched up with the y, then I know that that's the one that goes this way. So then the square root of 9 gives me 3, and I know my y distance is 3. So then 3 here, 3 here. Okay. All right, you have 2 where you are writing the equation for the ellipse. So look at the next one. Try to find the center for me. This is a little bit harder on an ellipse than it is on a circle. But remember, you just got to pick dead center sideways and then dead center up and down. So what I'm going to do is I'm going to count how long this is, and then I'm going to cut it in half. And then I'm going to count how long this is, and I'm going to cut it in half and make sure that I'm in the middle. If both sides don't match, you didn't find the center right. So let's say I think it's right here. Well, then I'll count 1, 2, 3, 4. 1, 2, 3, 4. Check. I know I'm in the middle. Then I'll count up 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Then I know check, that one is 7. So I'm going to put R equals 7, this R equals. Now remember, technically they're not R's because a radius is only really for a circle, but I'm just going to call it that. Okay, so what's my center? What's my ordered pair? 4, 1. And then when I put my parentheses, I'm going to reverse the sign. So if it's a positive 4, I'm going to do an x minus 4 squared. If it's a positive 1, I'm going to do a y minus 1 squared. And then I always know it's a 1 on the other side. Then the only other two numbers you need to put are the numbers on the bottom. So x has to go with the x distance, which was how long? 4. Then what will I put on the bottom? 16. Okay, then my y distance was here. Remember, we said it was 7. Then I put a 49. Does that make sense? Okay, but the center is the same, but it's equal to 1. And then you just have to count your x and y distance. Okay, one more like that. Take a look at the next one. Okay, what I tried to do is just like draw a line across and then a line up and down, but make sure that you count to make sure that you have the real center. So let's do up and down first. I see that it's 1, 2, 3 and 1, 2, 3. So I know that R is 3. Okay, then I'm going to count side to side. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Okay. Then from there, I'm going to find my center after I check that it's the real center. I see my center is -3, -1. And then remember, if they're negative in the parentheses, they're going to be positive when you put them into your equation. So it'll be an x plus 3 squared and a y plus 1 squared, always equal to 1. And then what number will I put under x? 3 squared or 6 squared? 6 is the horizontal, then that's the one that goes here. And then my y distance was 3, so I would put a 9 on the bottom. Easy enough? Okay, the last thing that we have to talk about is what if your equation starts off in the wrong form? So we covered how to do this with circles. If you know how to do it with circles, it's actually quite similar. So turn the page and take a look at your last section. What did we do? Oh, okay. I forgot about these. All you have to do is, what is this number supposed to be? A 1, then divide by that number. And then what's going to happen if I have 28 divided by 28 here? And then I have to leave something on the bottom though. So what could I leave? Leave a 1. Okay, and then in this case, the reason I had you get a calculator is that we can't leave it with a 7 in front and a 28 on bottom, so we have to divide those. What is 28 if I divide it with a 7? Then that should just be a 4 on the bottom. Does that make sense? And then 28 divided by 28 here, that would give you 1. So I'm not going to make you actually do this one, but I want you to rewrite it. It'd be x minus 2 squared over 1. Y minus 5 squared over 4. And then a 1. If you don't know how to do this, all you have to do is right here, you would type in, watch, 7 divided by 28. 7 divided by 28. And then you can hit math, enter, and it'll show you that that's the same as something, or just a 4 on the bottom. But if you want to think about, just divide the number on bottom by the number on top, but keep it on the top. Okay, let's do the one right next to it. We have a 36. That's not what's supposed to be there. So divide by 36. but you have to do it all the way across. And then what is 36 divided by 4 for the number that's going to be on bottom here? That will be an over 9. And then what about 36 divided by 9 here? What's that radius going to be? 36 divided by 9 is a 4, and then 36 divided by 36 is. Okay, so pretty similar to if you have the number on the other side, you just reduce it with what's already there if it's in the front. Okay, so now take a look at number 9. Okay, and then hopefully you could graph those and those would have been not too bad. Okay, what did we do first with circles? Okay, the first thing we would have done is put them in order. But as you can see here, your X's are already together and your Y's are already together. My X's are both right here. My Y's are both right here. And then I have my GCF over here on the other side. Okay, but when it's an ellipse, you're going to have a GCF that the X's have in common. And then you're going to have a GCF that the Y's have in common. So look at your two X's. What do both of these have in common? What number could I divide both of those by? What number?
2.
2. So then I'd have an X squared left over. And then what is 16 if I divide it by 2 for my next term? 8X. And then leave a blank, just like we did yesterday or 2 days ago. Okay, now look at your Y's. What do your Y's have in common? What number? 50. Then I'm going to put the 50 on the outside. And I'm going to divide it out. So 50 divided by 50, that's going to cross out and just give me the Y squared. What about the 100Y divided by 50? 2. Leave a blank, and then negative 32. Then you're going to do the exact same step that we learned on Tuesday. It's called complete the square. You can only take half of this number in the middle. So if it's a -8, what's half of that? X minus 4. Okay, but the only difference is that now look, instead of it just being this parentheses, there's a 2 in front. What number am I going to fill in the blank with? What's 4 squared? 16. And now here's the problem. I can't add 16 across because what's waiting on the outside of this to times with the 16? So what is 2 times 16? Then I need to add a 32 over. Does that make sense? So you're still filling in that blank with the complete the square number, but you have to remember to multiply it by what's waiting on the outside before you add it. Okay, next one. I have a 50 on the outside, Y squared plus 2Y, but I can only take half. What's half of 2? Okay, Y plus 1 squared. Then I do 1 squared. What do I get? 1. I put a 1 on the inside, but what do I add on the other side? 1 times 50 is 50. And then from there, you have to add up all 3 of these numbers to know what your answer is over here. So I'll have negative 32 plus 32 plus 50, and I get 50. Easier way to think about that is these kind of just cross out. Okay, now if this was a circle, I'd be done, but I'm not, because what is an ellipse supposed to be equal to? What number? A 1. And how do I get rid of the number right here that we just talked about? Divide. So over 50, over 50, over 50. Okay, if there's a number on the outside, you have to divide them. So for example, here, what's 50 divided by 2? What's 50 divided by 2? Bless you. So a 25 on the bottom. Next one, I have a 50 divided by 50. What's my number on the bottom going to be? A 1. So Y plus 1 squared over 1. And then 50 divided by 50, that's your 1 that's supposed to. Then from there, let's just do our graph. What is our center going to be? Positive 4, negative 1, so that'd be here. And then what is my X radius gonna be if it's a 25 on the bottom? So I'll go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. What is my Y distance gonna be if it's a 1 on the bottom? Square root of 1 is just a, so then I'll go up 1 and down 1. And so that one's really wide, but not very tall. Make sense? So if you were here Tuesday, the different steps are you're going to have a GCF with the X's and the Y's, and then you have to remember to divide at the end. So let's work through one more of those. I think there are 2 left, but let's do one more and see. You have your steps written out on the next example if you want them. Okay, first thing you're going to do is group your X terms together. Then group your Y terms together, and then you're going to GCF. So all X terms, GCF. Then all Y terms, then GCF. Okay, if there's a number by itself, remember we move that across to the other side. So let's take a look at this one. Also, don't forget to leave your blanks. So out of my X's, do I have a GCF there? A number GCF? It's okay if the answer is no. Do we have one? No. So X squared minus 4X, leave a blank. Okay, now we're going to our Y's. 4Y squared plus 24Y. Do I have a GCF there? Bigger than 2? 4. And then my 4Y squared divided by 4 is just a Y squared. My 24 divided by 4, that's a 6Y. Blank before you close the parentheses. Okay, and then where's the minus 24 supposed to be? We got to move it. Move it over to the right. Now it will be what though? Plus 24. Very good. Okay, from there, complete the square. We're going to cut the middle term in half. So if it's a minus 4, what's half of that? Negative 2. What is negative 2 squared? 4. And it, remember, it's always plus because your negative would have crossed out. Okay, is there a number waiting on the outside for me to multiply that one? Not for the X's, which is fine. Okay, now let's do it for the Y's. What's half of my middle term here? Y plus 3. What's 3 squared for me to fill in the blank? 9. And then do I add a 9 across? 9 times what? 4 would be 36. And then from there, we have our 4 in the front on the purples that I forgot to write, equal to, that'd be 60. Okay. Then from there, how do we get rid of the 60? Divide. So you'd have X minus 2 squared over 60. And then divide 60 by 4. I don't know what that is. So let's see. 60 divided by 4 is, oh wait, 15, I think. Okay, 15. And then a 1. Now, are 60 and 15 perfect squares? Yes? That's why it didn't come out to a perfect number. Dang. Okay, now it's a 64. There we go. Thanks. Thanks, ladies. Okay, so we're changing this to a 64. So now 64 is good. And then what is this one going to be? What is 64 divided by 4 for my bottom number? You have a calculator? Yes? 64 divided by 4? Huh? 16. So instead of 15, now it's the perfect square. And then from there, I would go to my center. What's my center going to be? 2, negative 3. So that would be here. And then square root your bottom numbers. What's the square root of 64 here? 8. So I'll go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then I'll go up and down the square root of the number under y. So if it's a 16, I'll go 1, 2, 3, 4, and 1, 2. Okay, for your homework, all of these numbers on the bottom should come out to be perfect, like perfect squares that you can square root. All right, last example. Look at your x's. What can I take out? Just a number, can't be a letter. Thank you, 9. What's left over when I divide the 9 out? Now it's just an x squared. 18 divided by 9, now that's a 2x. Blank. Don't forget your blanks. Okay, then next one, I have a 25y squared minus 100. I can take out a 25. 25 divided by 25 gives me a regular y squared, and 100 divided by 25 gives me a 4y. Do I have to move my 791 across? It's already over there, so that's fine. Just leave it. Okay, from there, we can only take half. What's half of the 2 in the middle? X plus 1. And then what's 1 squared for me to fill in the blank? 1, and then 1 times what? 9 means I'm adding a 9. Okay, then on the other side, I can only take half. So half of -4 would be -2. And then what's 2 squared for me to fill in the blank? 4. And then 4 times the 25. What do I add across? 100. And then you'll add up those numbers and see what you get. So 791 plus 9 plus 100 gives me 900. Can I leave that as a 900? Is that allowed for ellipses? No. So the way we get rid of it is we divide the 900 across to be on the bottom for all the fractions. So I'll put over 900, over 900, over 900. And then remember, you're dividing the bottom by the top so that you know what to put down there. They should always be perfect squares. If they're not, you probably messed up. Okay, so x plus 1 squared. What is 900 divided by 9? 100. What is 900 divided by 25? Okay, perfect, 36. And then 900 divided by 900 is 0. Questions on that? It's kind of a lot of steps, but if you already know the steps from last time, then hopefully it's not too bad. Your homework's online. Do we need to do one together? You got it. Got it? Okay. Ask me if you need help. If you need to reset, that's fine. And you can do it. Let me just close this.